Hey, Rad. How's it going?
Hey guys. Yeah, good. How are you, Saj?
Good. Happy New
Happy New
Year.
Year to all. Thanks.
So far. I don't know. There's nothing on the agenda, so I don't know if we're gonna get much tonight. We'll see.
Wasn't there a couple of things from Noah there?
Oh, maybe he added Oh yeah, there we go. Yes. Yeah, got two things. All right, cool.
Was David here a minute ago? David Zaffman?
I don't think so.
Okay. I thought I heard someone talking when I joined, but anyway, sounded like him.
You know,
Hello.
how's it going?
Good. I have a quick question for you before we do this
Yes.
thing.
Yep.
Uh, on when you're adding a new monitor,
Mm-hmm.
um, the I was thinking that you would be able to do the minimal Ceph conf with just mon init like just mon host equal.
Mm-hmm.
Um, but at least in Mimic, I was trying. It still seems to be complaining that it doesn't have like public adder. So I'm
So
wondering if
if
there's like another
in that
piece to that.
case, yeah, the requirement is basically that the new monitor just be told what address to bind to. Normally it
Okay.
infers
All right.
that from on host, but in this case it doesn't have that. So
Yeah.
you should just pass public adder or public
Okay.
network.
Yeah.
Except it's hard to know what that is. It's yeah, that's why adding monitors is a little bit tricky. um,
Yeah, there's a bunch of stuff going on in Ceph deploy to like guess something decent, but maybe I can just use
yeah.
that unless you have a better idea.
Um, wonder if yeah, I don't know. I wonder if it should. We could make the orchestrator command require that you specify. That's kind of like in the Kubernetes case, you're just going to like add a bunch and remove a bunch. So, but instead we could basically require that you define public network for the mon section. That could do it.
Okay.
That makes sense. But it's a little bit weird because for the monitors, it has to go in the ceph.conf for annoying. Well, you could try to find a public network setting from the configs.
In the docs, it seems to be in the docs at least. It's like when you're adding a new one, you can do it from CLI.
Yeah.
Is that what you're talking about? Yeah.
Yeah. Yeah. I'm just trying to think how this would wire into the orchestrator abstraction because in that case, in the rook case, it's just like add one, remove one.
Right. Yeah.
Four of them. But I guess maybe I don't know if that matters. I can't remember what the CLI like. Yeah, I'm not sure.
That's all right.
Yeah. Maybe let's talk about it tomorrow.
So we're waiting for the demo, so we can figure out the details later.
Yeah. I mean,
Okay.
for the time being, you can just specify the public network in the ceph.conf, and that'll do the trick.
Cool.
All right. What else? Looks like everything is all you. You want to go ahead and start?
Sure. So there's a couple projects that are building apps on Rados. And there's a few features that would be really nice to have.
Which projects, out of curiosity?
Zlog and then Skyhook. I think Jeff's on the
Okay.
call too.
Yeah, Jeff.
Hey guys, hi.
Cool. Okay.
So we have like a lot of use cases, but we try to boil it down and they're like pretty easy to digest. So I don't know which one's first on the list. I don't have the CDM. Is it the
That's
PG one?
Yeah, PG Ops. I just pasted it in the chat.
Okay. Yeah. So so there's a couple of use cases for this. Really, what we'd like to do is be able to define some custom PG ops, very analogous to like object class methods. And we'd like them to run with the same atomicity semantics as object operations.
Okay.
And I think that is already the case, although I'm not sure. And then the two use cases that we have, which are pretty compelling, are we have some cases where we'd like to put a guard in front of object operations, but we'd like to do it scalably at the pool level. So we don't want to iterate over all the objects to update this value that's being checked on the object IO path. So this is like, there's a bunch of use cases for this.
Can you give an example of a guard, like checking a name or checking an attribute or something like that?
Yeah, so like the simplest case is that we'd have like an application level epoch value or version value that we're controlling. And then the app one is going to go around and like update this value on each PG, but then all of the object operations would do a read and just make sure that their assumptions are correct. It's really a scalable way to do some really lightweight synchronization between clients. I think there's a case in Skyhook where we're interested in doing collection level locking, but we need to do this. We want to just do the coordination through Rados.
By collection, you mean Rados pool?
Yeah, but it's not necessarily at that granularity. It's like arbitrary groupings of objects. So it'd be like a table level lock in Skyhook, but that table is like in number of objects.
Yeah. So the problem here is that I think using the word scalable is misleading. You can get to the point where you basically push the enumeration over objects into the OSD, but it's still O num objects. It's just the OSD that's doing iteration, and you're not iterating across the wire.
We don't need to change the state of all the objects. So we're not talking about pushing an op to the PG level and then doing a local iteration over the objects.
Oh, I see. Okay.
We'd like to have like a value that says, like foo.version in the PG. There's only one value, physically one value of this. And then in the IO path for an object operation, we would just read this one value from the PG.
I see.
So just to be clear,
coordination.
You're looking for PG level metadata, or actually, well, not even metadata.
Right.
You want to be able to write data that belongs to a PG rather than to an object. Right?
Yes, yeah,
Yes.
exactly.
I see.
But we want to read it in the object IO path in CLS, and I think, yeah. Anyways.
Do you really mean a PG level thing, or is it really a pool level thing?
Well, so I think that I think it's PG level, and that's only because I think that we may have situations where we don't want to keep the metadata at the pool abstraction, like because we might have subsets. I mean, I think both could work.
Well, yeah, but if you have subsets of data within a pool, that implies that you're somehow like filtering your object names to fit within PGs, which, yes, is a thing that you as an informed user might figure out how to hack, but isn't something that we as Ceph developers want you to do because we want to be able to change PG counts and for you to not notice that.
Yeah. I think the thing to keep in mind is that PGs are the PG count is changing. It can increase and decrease. PGs are splitting and merging at any point in time.
Yeah, so I had considered this, and I don't know. I mean, from my point of view, the PG count would change very infrequently, although maybe that's a terrible assumption to have. And so if I just knew the version of PG map, I could deal with those changes at a high level. But you know, I'd have to give it a little more thought. But I think if this was pool level metadata, that could also work.
Because it sounds like what you want to do is you want to set like table foo.epic equals 12, and you want to set that sort of globally for the entire data set.
Right.
And then have Rados op guards that check the pool attribute equal to 12 or greater than equal to 12 or whatever, do your little comparison operation. And having it sharded by PG actually seems harder because then you are when you set it, you have to set it, PG num times. You have to iterate over every placement group and set it for each PG.
That
right?
I mean, that's significantly better than doing it over every object. And
True. But what you're really after is setting it for the whole pool, right?
Yeah. So in this limited case, it is true that I think pool level metadata would work as long as we can identify. Like I need to be able to block until I know that all future IOs are going to see the updated metadata.
Yeah. So I mean, that's
as long as that's possible.
Exactly what an OSD map does once you know it's there.
Yeah.
Like you can't force all other client IO to block, but you can, like, it's not going to go until the OSD has seen the thing that you have seen.
I don't need any IO to block. I just need to point to a position in time where I know future IOs are going to see the updated.
Yeah. So I think we even have a place you can put this already.
Interesting.
I mean, we have full metadata.
Yeah, it's really targeted at the admin, but yeah, it's like semi-structured in that it's encoded efficiently, and that if you don't set a property, then it doesn't get encoded. But it's the properties that you're allowed to set are hard-coded. So they're all they all control Rails behavior. There's no user metadata payload.
Right.
But we could add it.
And we've got the applications that you can set. So there's Ceph.
Oh yeah, actually yeah.
I don't remember what that actually lives in, but I that's freeform, I think.
Yeah.
So we can set something like that.
But I think so assuming you go down the road of putting it in the OSD map, then the question is is that sufficiently scalable? Because this is a data structure that every client has in memory. So if you have 1 million tables, it's not going to work. If you have 10 tables, it'll work great, right? If you have 1,000, I don't know what's going to happen.
My concern is that still applies even if you're trying to put it in a PG, though, because if it lives on a PG, then you're basically building up giant objects that don't have a defined place they live in the PG. I mean, we pick a place, but then it's
they got to be in memory.
That every single, but I mean, going back to what Noah was asking for initially, there are some problems with that. It's an object that you need to be on every OSD before any IO happens, and that needs to be backfilled, and you need to be able to block on it. And we used to have stuff like this with the object clones and the side-by-side objects with the object locators, and we killed it all because
it was horrible.
You would backfill and ops would just suddenly stop working and you wouldn't know why. And so the reason we're pushing hard on this is because what you asked for is really, really scary.
Makes it hard.
Now, I mean, we've talked about PG level ops in the past a lot for things like where Sage went initially, where you're doing a listing and searching through each object's metadata or something.
How were the hit sets?
That would be exciting.
The hit sets were for PG, right?
What?
The hit sets?
are per PG, yes.
Yes.
But when you split, we just copy them. When we merge,
Yeah,
we just throw one of them out.
and nothing depends on them for reading.
Yeah.
Like,
It's a
they're a
heuristic
write
for
only data structure, basically.
Okay.
Yeah.
Hmm.
Yeah, it's a tricky thing to make scalable.
So I think it's unclear. Well, maybe it would help to separate the two cases. So I think there is a case. So in the Zlog case, it really is a very tiny amount of metadata per pool, and it's not going to scale up. It's just constant. I think that you're right about that. That might not work for all the different use cases that exist in Skyhook. Like
right. Where you have one per Postgres table, right?
Right.
But what would happen in Skyhook if instead of having one epic per table, you had a global epic?
Per pool?
Yeah, per pool instead of per table. That means that anytime you had a view change on any any table, then sort of all of the pool operations would have to like retry or reorder or whatever it is, right?
Yeah, my hunch is that it's not gonna give you the granularity you want.
Yeah.
But now we're like sort of wading into more sophisticated version control schemes for the transactions. So
Yeah.
may have to give it like a little bit more thought on how that would play with the multi-version schemes.
Yeah. I mean, I guess I have one. It would be nice to basically reach for something like watch notify, where the clients are using a cooperative scheme to coordinate their writes. The problem there is that there's sort of a fundamental issue with watch notify where when the client goes away and fails, you have to wait for a certain amount of time for the operations to time out before you like go into some recovery mode or something.
Mm.
And that might not be appropriate for a database. That's an HA database. But I don't really know. Maybe that isn't an issue because failover in Postgres is already going to be super coarse grained anyway. Like you're going to wait tens or seconds or a minute or whatever before you fail over.
Right.
But
well, honestly, I thought it was going to be a slam dunk and just split. But it sounds like maybe we need to have, so like for the tiny amount of metadata, the pool makes sense. For this other thing, we should probably
have to have a more detailed discussion to understand what the goal is.
Well, yeah. So for this table level locking was really an intermediate solution before we went more fine grained. So if it sounds like it's kind of a important sort of design on the Ceph side, we might be able to just like take the
skip to
time
the end.
and come up. Yeah, exactly.
Yeah. That makes sense. Yeah.
Okay. What do you think?
Is there
Yeah, I see. Yeah.
Can you give like a quick summary of what the end goal is?
Or even what
So,
Skyhook is?
Yeah. Yeah. I don't know if there's an intro, if you have a document or page you can share on Skyhook in general, but.
So, Jeff, do you have
there's like a picture on the wiki of the architecture if you like.
Sure, that'd be good. That'd be a start.
Let's see. But the goal here is just to coordinate all of the objects that comprise a single table and increment their version number when we do an update to any row. And coordinating at the PG level was a little less order than the number of objects, rather than doing it all across every object.
Yeah.
I think I lost my page.
So,
But it's
so
really
really
just for
briefly,
coordination of that.
yeah, maybe we can just say like what Skyhook is. So like really briefly, Skyhook is the bottom half of Postgres or MySQL that manages table level data. That table level data is chopped up and stored as objects in Ceph. So fundamentally, the objects are storing relational rows. But you end up in a situation where you need to actually have a lot more intelligence at the storage level than just reads and writes. So we're going to be controlling things like transactional consistency. So there's a lot of metadata flying around that we need to track. And some of that metadata is harder to scale than others. And so there's things like table level locking, which is a coarse grain solution, but it just gets more complicated from there.
Yeah. Well, let's look at that. Let's look at the other one and see. Oh, it makes sense.
Sure. Well, before we move to the other item, I think there was one other use case that's sort of distinct from the ones we were talking about. So there's another use case for what I had sort of envisioned as PG level ops, where we're also tracking metadata on a per PG basis. But this might be like intermediate indexing. So we may have like, like the most naive version might be tracking like min max values per object. So like a small amount of per object metadata that lets us filter out objects from further investigation. So we can query on rows based on column predicate. But then we can just sort of say like this object certainly doesn't have what we want because it doesn't land in the range that we'd recorded. And so for that, it really helps because if we wanted to do that at a high level, we'd have like say 1,000 object round trips, where if there were 1,000 objects in the PG, it would be a lot more efficient to just do one round trip and do local metadata operations.
Well, even in that case, it wouldn't be one round trip, it would be PG num round trips. Because you'd have to ask each PG.
Totally fine.
Okay, so it helps if you have a million objects. If you have 1,000 objects, it might not be that big a win.
Yeah, so we had like we did some experiments last year where it was like, we had realistic TPC queries with like 1 billion rows. So we had situations where we could do like 1,000 round trips, one per PG, to do these aggregates. We had like multiple orders of magnitude speed up versus we had like, I don't know, 100,000 objects or something. Those latencies add up big time.
So is this the type of thing where you could have each object maintain its local min max as an attribute, and then you could build an index over specific object attributes?
Yes.
Right now they do contain min max, so we can compute some aggregates and stats values per object. And this would be a way to sort of aggregate those.
Right. So what it would really be is it would be like a table name and then min max, or it's like table.row.min and table.row.max, like that, right?
That's
There's
right.
be a couple
That's right.
different attributes. Okay.
That's right.
Yeah, so something where you're like
Table partition.
on the state, like and asking for a list of all the objects that satisfy that read condition is something I'm a lot more interested in, and we've been more comfortable with in the past. So in fact, we actually have something sort of like this. There's a PGLS filter. I
Mm-hmm.
don't know if you guys have seen this, and I don't remember what all it matches with. It might only be name based, but I know RTW uses that for doing some searches, and the file system does for when it's looking for, I think, directories to do its backwards scrub and repair stuff.
Mhm. But it's doing it's enumerating objects and then checking each object though. It's not actually an index.
Yeah. So yeah, that's.
But it could benefit from this.
What?
It would benefit from this big time. I mean, this might be, assuming this thing existed, it might generalize the snap mapper too, although it would be internal metadata instead of user-facing metadata. But the thing that worries me is that
that's what I'm trying to understand. I wasn't clear about that. Are you guys actually trying to build an index that's maintained live while you do object ops? Or do you just want to be able to do searches on the attributes that objects have?
Yeah, we'd want to put them all inline, transactionally update those as part of an object operation.
I see. Okay.
So I think it has all the same problems and benefits that SnapMapper does, which might be helpful to just sort of the issues. The problem with SnapMapper is that it's not a global, it's basically a per pool index, effectively. It doesn't live inside the PG because PG split and merge, and you don't want to have to rewrite and resort the index. And in fact, in general, that's not an efficient thing to do. So, or maybe it is. I mean, whatever. It'd be order in, but it'd be more efficient, I guess, if it were for PG. But that means that we're basically just pushing all the Atomicity transactional stuff down into RocksDB, which works fine today. Excuse me. It works fine today because we have RocksDB underneath, and it's just, has its own big global lock, and so and we aren't hitting it quite hard enough that it has mattered, or maybe we are. Maybe you can argue with Mark about that. But this will have the same issues basically, in that you have independent operations on different PGs, different objects that both have to atomically update this shared index structure that's global to the OSD that's sitting underneath. And so that might cause more contention, even on like today's OSD. But it makes life really hard when you start thinking about the sort of the future Crimson OSD, where we want to be much more explicit and much more strict about the sharding, so that we can really shard more aggressively across the PGs. Because you have the shared index structure that's being modified by two PGs. The fact that and the size of the index is order the number of objects is kind of problematic. Even if you have multiple indexes and objects only exist in certain indexes based on their table names or something like that, the total amount of indexed data is still order of the number of objects in the pool, assuming that they all get indexed.
Sure.
So, if you were to do this by actually having per PG indexes, that means that when you merge two PGs, you have to do this big merge of these two structures. That's going to be a big latency blip. Or when you split, you have to actually do the same thing. And so far, we've done a pretty good job of making split and merge not do that. The exception of merge has a bit of a blip, but it's rare. But it's not an order. The processing delay is not related to the amount of work we have to do. It's related to like ordering operations or whatever, and it's independent of the size of the pool and all that. So it gets a little
This would
tricky.
grow with the number of, yeah. Right.
Just set the flag. Don't change num PGs. Lock it up.
Yeah, I mean, we could if you were to if we knew that there was like a maximum degree of sharding in the pool, for example, we could just like pre-shard the index so that if you have one PG, you actually have 100 little indexes to update, and you any particular object is only going to modify one of those shards. And when you do a query, you sort of walk across them. Or if you had an index structure that sort of naturally lended itself to being resharded at the same, I think that's the wrong direction. I'm not sure that would actually work.
Well,
But
depending on what it ended up looking like. I mean, even for some applications, stop the world events can be okay if we know when they're going to happen.
Yeah, I don't know if you know them. They're going to happen in this case because it's Rados.
Are you
like
talking about the auto PG, or does the splitting happen in other places?
Well, in general, it's going to be the administrator who's deciding when to split and merge, or it's going to be some like background process that's deciding when to split and merge. And Nautilus,
yeah.
the Met cluster will do it on its own.
We'll turn that off so we can know.
I guess. Yeah.
Okay. All right. I think we have some more homework to do then on this.
Yeah.
I think you want to think real hard about what exactly you're trying to push into the Ceph cluster versus what you're doing on your own, because like it sounds like you when you're talking about PG metadata or like PG level indexes, you're basically asking for cross object atomic operations. And you think that you're like saying, oh, it's on the PG, so it's free, but that's just not as true as you might like it to be. So maybe try and figure out like what kinds of operations you need to do, and if we can break it into smaller pieces that maybe we could make happen. Like we don't have anything that works on that works on a PG level that's accessible to people, but maybe we could come up with something where we're like, okay, we want a PG op, and so like we're like and we know what versions of these 10 objects we're working on, and so like run a thing on these 10 objects and store the data in this other object that's also there. Like I don't know, I haven't thought of this before, so I'm not saying that will work, but that's a lot more plausible than what I've heard so far.
Okay.
Because
Yeah,
like Sage is being really nice. We talked about the snap mapper, and it's like, okay, so we have the snap mapper that sort of is like this, but it's like the degenerate case. It doesn't like it stores a version, like a set of versions for objects, but only when those versions exist. And
it's only when right.
It's throughout the entire Rados code base, not just like a set of random data, and it works pretty well now. But it didn't.
It's also a pain in the ass.
Or maybe it did 4 years ago. It didn't 7 years ago. We found a bug like the beginning of last year. I guess it's 2 years now.
We're still chasing a bug in SnapMapper.
Oh my gosh.
But anyway, yeah.
Well, we'd like to make that more complicated.
Backfill and everything.
Exactly.
It's this giant set of data that needs to be there all the time. And that we can't sort of move in pieces.
I think it's hard because I can see a million uses for a reverse index. It would be a pretty powerful thing. At the same time, we've managed to build a bunch of like robust, complete stuff on top of the sort of the more primitive stuff that Rados does today. And so it's hard to, I don't know. It's hard to argue that we need to make it more complicated because it's already very complicated and a challenge.
Yeah, I think that's a good point. Like a lot of this stuff we really can do at a higher level. It's just a lot more interesting to it in the storage system.
Yeah. Well, I mean, it can be a layer
Yeah.
sitting on top of Rados. Like RGW is a layer that sits on top of Rados that does
Right.
indexes and quotas and garbage collection and everything under the
Yeah.
sun, right?
Yeah. Yeah, that's a good point. So, all right.
What you suggested with write to another object, though, that might actually, something along those lines might be pretty interesting for us. So we'll think about that some more.
And I mean, I want to be clear that that's still a big thing. Like if it were to work, you would have to like be able to specify like the versions of the objects you're reading from and the version of the one you're writing to, or something, in order for us
Right.
to reasonably safe about it.
Okay.
Are we talking about the multi-object transactions?
Well, no, this would have to be a thing that runs on a PG, and just like if it's doing backflow or something, it just blocks until it has all the objects, but not across PGs. And I think we can make that work more easily because we can just grab the metadata and say yes, it matches, and we're not back. We know we have the latest versions of these, so we're good.
It's just the split and merge are the thing that always come back to you.
Yeah.
Okay. Split and merge. So consider that
Yeah.
be the problem right now. Okay. All right. All right. Well, I don't want to dwell on this one too long. I think that was good. So, so the next one is pretty simple, I think. We have some use cases for allowing some data to be returned when OSD ops mutate. So like right now, if you do a read in an object class method, if you do a write in an object class method, then any data you return just gets tossed away.
Yep.
Yeah, it would be nice to be able to return some data, and it doesn't have to be a lot. Fundamentally, we're returning data right now because we're returning the return value.
Yeah.
So it doesn't. So like whatever mechanism is happening there, it would be really nice to piggyback on that because.
Yep.
Well, anyways, I can talk about the use cases, or we can just jump right to it.
I believe the use cases, and I think we've encountered.
Yeah.
I'm sure.
And sorry, so just there, we did actually finally start returning a real return code, right?
Yep.
That is done.
Yeah, that was in
Okay.
Hammer Jewel. It was in Jewel, maybe. I can't remember. I think Josh did most of the work.
Okay.
It was a while ago.
Okay.
So the it's pretty luminous. I think it was Jewel. Anyway, so it goes in the PG log.
Yeah.
Is where the error code is recorded. And when you send it's because the writes have to be idempotent. So if you resend an op, it's the PG log or the adjacent structure that's consulted to see if that operation is a replay, and if so, then it returns the same value that it recorded. So it's pretty easy to extend that to include a payload. It just means that the PG log has the potential to get bigger.
Yeah.
If we're talking about 16 bytes, I'm not too concerned because there's already PG log entries already have a bunch of other stuff. And erasure coded pools, for example, they have a copy of all the attributes for the object for every time you write something like that. Or maybe just a change once, I can't remember, but it's like on that order. So it's, or at least it did in the old, maybe with the, it's possible with the new overwrite Rados stuff, we don't need that anymore, but previously we did. But in any case, yeah, it would be reasonable, I think, to include it there, as long as it's bounded. And I think, 16 bytes sounds reasonable enough. There is actually an open bug for this, for something similar to this, and that is, I think maybe just poor API design. When you do a Rados operation that has multiple items and the multiple operations in the operation, in the normal case, we record a return value for each one and return the return value for each one to the client. But the PG log only records the overall return value for the whole thing, which is usually the last one or the one that failed, and not for the intermediate ones. And there are some tests that are doing writes and looking at the return value for the individual operations. They're just, right now it's unit tests that fail in the so if you have an ill-timed reset where it has to resend that op and it hits the replay, whatever returns the return value, then the intermediate sub operation code doesn't match. And it's the same basic problem. We just need to either get rid of that or store more metadata in the PG log entry.
That one's actually a lot harder because you can have arbitrary sub out numbers.
Arbitrary sub out numbers. An arbitrary number of them, you mean?
Yeah. An arbitrary number of sub ops can go into an object
Yeah.
operation.
Yeah, you could have 50 and not just 16 bytes worth.
Yeah.
In practice, you don't really.
We actually return those in a write.
Yeah, I don't know if anything really needs it, so it's like maybe we should get rid of that.
Yeah.
But it does exist, and there is a functional test that tests that in the Liberatus test suite or whatever
So
that fails every.
why isn't the return code good enough to know if you want 16 bytes? Is it you need two 64-bit numbers or specifically, or?
I mean, I think there's well, so for my specific use case, I want a 64-bit number plus some metadata, and that happens to fit in 16 bytes. But 16 bytes also seems like enough that if you really wanted to return a larger amount of data that was atomically consistent with an update, you could stash it in the object and just return some sort of unique identifier.
I mean, 16 bytes is reasonable. It's just I want to have a really good reason to make it 16 bytes instead of byte return code.
I mean, so
it won't be like super hard, I don't think, but there is more memory usage, and it'll also restrict what we can do in the future to optimize that.
Yeah, I mean, so I'll use all 64. Well, I guess I won't use all 64. Well, I'm going to use more than 32 and 32 bits, and like that's what the current data types are. I mean, I guess I could. So,
return code is 64, isn't it, or is that only 32?
32, I think.
Oh, okay.
32.
Okay. Anyway, just like I would want a really persuasive argument for why the number we have is correct and will work. Before we do go to the effort of it.
I have a feeling this is like going to be like the maximum object size or the maximum number of attributes or the maximum size of an attribute. Like they're all in some sense arbitrary. You just pick a value that sort of like is sufficiently useful. Trade-off.
Yeah. Maybe.
I mean, this could even be something that like you set as a pool property or something, right? Where this pool operations have this much allowed write payload.
Sure.
And the main purpose of it is just to like prevent a poorly behaved operation from putting like 2 megs in the buffer list and returning it and blowing up.
Yeah.
It'll just that or do something. I don't know.
Yeah, I think that go ahead.
I mean, it wouldn't be. Say you set the limit at 16 bytes. Like if every 100th operation sets this, but the other 99% don't set it, then like it would be fine if that 1% sets it to like a kilobyte. Right, the overhead would be similar.
Yeah.
More a matter of there needs to be some cap, and it needs to be that with knowledge that this is going to the PG log and it's going to consume memory.
And 16 would give enough for, the return code, and then also an 8 byte, like 2 8 bytes, right? So one could be the value, like an incremental version number.
I mean, if I were doing
second
it,
ID,
I would keep the current return value, the 32-bit return value, and just add a buffer list. I mean, it could just be the same output that we right now. We toss it on the floor. We could just keep it and cap it at whatever the max size is.
Right. It seems like all of the plumbing is already there.
Yeah. Except for storing it in the PG log entry T, and in the same time that we fetch the return code when we're doing a replay op, we also would fetch that. It would be pretty easy to implement.
Yeah. Okay. Okay, cool.
That doesn't really address the other problem of having all the return values for all the subops. That could be fixed at the same time, either by storing all of those values in the pgelog entry tree or getting rid of that behavior entirely.
Is
I
this
think it made
specifically?
Sorry.
Is this specifically so that clients can get back like a vector of return values or something, or
Yeah,
what?
yeah.
Okay.
It made sense at the time because for reads, it made sense for reads, and I think reads and writes are sort of similar, and so the writes got them for free without really thinking about it. But the way that the ops are set up, for each op, you have an input and output buffer and a return value, and you like have n in them in your transaction.
Yeah.
And so I think for reads, it's genuinely useful, right? You can put real use information in there. For writes, I don't really know
Exactly.
what you use it for. Clear what the purpose is. I don't have a use case in mind.
Knowing which thing failed, because you might have a step of 5 things and want to know which one, like which precondition would go through.
That's true.
But yeah, I mean, like Wrights got it by accident. It's because we had, like, each of those sub ops is processed by running it through the Duo SDOP machinery, and that fills in the return, the like sub op return code.
I think in practice they're usually always 0, so we could fix that bug just by storing only the non-zero ones. And yes, if you put a bazillion write ops that are returning non-zero return codes in the same transaction, then you'd have big pgelog entries, but maybe that doesn't matter. I don't know. Or we could just make them non-existent for write operations.
I really wish Josh or someone was here, because I feel like there was another problem with sticking extra data into pglog, and I can't think of what it would have been.
Well,
Maybe
we're sort of simplifying.
We're doing the return codes.
We're kind of ignoring that. So there's this new thing that got added around Luminous that is the dupop table. The goal was to reduce the number of pglog entries that we have in memory, but we still need enough duplicate ops in memory.
That's not why, though. It was something else, like about being able to build the transaction efficiently with data like that was set that late, which doesn't make sense either, because that doesn't seem like it would be hard. But maybe it was a problem and it got fixed up as a result of the earlier work. I don't know, but like people have tried to do this before and not been successful. Anyway.
Yeah. Well, I guess the implementation needs to handle both the pglog entries and the dupop entries, because they both have to have the same information.
But yeah, that's all right next to each other though. So if you get one, it won't be difficult to do the other.
Anyway, that one's more doable. Your first one.
Okay. All right.
Yeah.
Well, we'll come back with a much more compelling case for the first one. Although,
or not.
It may not work. All right, that's great.
Cool.
That's all I had.
All right. There's nothing else on the list. Anybody else have anything they want to discuss? All right. Nautilus is coming. 2019.
Cool.
Yay. All right. Have a good night, everyone.
All right.
Thanks a lot.
Thank you. Thanks a lot. Yeah. Good luck, guys.
See you, everyone.
Guys.
Happy New Year.
Take care.